we have sigma of n plus 1 polynomial exponential times exponential. So we need to use the ratio test, okay, since we have a polynomial times exponential. Okay, in any case, here the generic term an is n plus 1 times 3n over n cubed times 2n, and the next term would be an plus 1. Just replace n by n plus 1, n plus 1 plus 1, n plus 2 times 3 raised to n plus 1 over n plus 1 cubed times 2 raised to n plus 1. Now, so we are using the ratio test. We take the limit of absolute value, but all the terms are positive, so we don't need absolute value. Or we can write, if we like, an plus 1 over an, which is limit n goes to infinity of n plus 1, an plus 1, this fraction, n plus 2 times 3 n plus 1 over n plus 1 cubed times 2 raised to n plus 1 divided by an, divided by this fraction, which is same as multiply by the reciprocal, n cube on the top times 2n over n plus 1 times 3n. Now we want to factor 3 raised to n plus 1 as, like, if you have a raised to x plus y, that's same as a raised to x times a raised to y. So this is same as 3 raised to n times 3 raised to 1, and 3 raised to n, 3 raised to n we can cancel because everything is in product. So let me write that in next step. So limit n goes to infinity of n plus 2 3 raised to n times 3 raised to 1, which is 3, times n cubed times 2 raised to n on the top over n plus 1 cubed. Similarly, 2 raised to n plus 1 is same as 2 raised to n times 2 raised to 1, which is 2. Okay, and n plus 1, one more n plus 1, we should have made n plus 1 to the fourth, same thing. It's n plus 1 times 3n. Okay, we can combine, we can multiply these two. Then we have a couple of cancellation, 3 to the n, 3 to the n, 2 to the n, 2 to the n, and this limit is same as limit n goes to infinity of 3n cubed, let me put in the front, 3n cubed times n plus 2 over 2 n plus 1, n plus 1 cubed, and 3 of them, one more, so n plus 1 to the fourth. Okay, now when n goes to infinity, this is a polynomial, this is also kind of polynomial. I mean, we have n, but if we change this back to x, they become polynomial. Only the leading terms matter. So the leading term would be 3n cubed times n, 3n to the fourth plus smaller, just leading term. Same thing on the bottom, n plus 1 to the fourth. When we multiply n plus 1 4 times, n plus 1 multiply by itself, multiply by n plus 1 again 4 times, the leading term would be n to the fourth plus other, and multiply by 2, n to the fourth. Okay, n fourth cancel. We have now 3 halves, which is bigger than 1. Okay, then by the ratio test, the series diverges because we got bigger than 1. The given series diverges by the ratio test.